Hello everyone. Today I will be teaching the topic binary trees. So for learning binary trees, we must have a brief knowledge of of what nodes are and how linked lists work. So let me give a brief about linked list. Linked lists are just chain of elements where each element is called a node, and every node has a pointer to the next to its next neighbor. So every each and every node have two information. First is the data of the node, and second is the reference to the next node. Reference to the next node. So let's learn how to create a node. I'll be implementing this thing in Java, but similarly this will be implemented in all of the languages. Let's say we have a class called node. It has two things. First is its data or value, whatever we say it, and another is reference to the next node. That will surely be of the node type as well. We will say it node next. So in this way linked lists are made where a particular node holds, let's say this node holds the value 1, and it refers to, and it has the reference of another node which has value 2. It has a reference to another node which is value 3, and similarly it will terminate at a particular null value where we do not have any more elements to add on. And for creating a new node object, we just have to say, let's say our node n1 is equal to new node, and we will pass on a value to the constructor. We will also have a constructor for this particular class, like we will say node which will be having which will consume a particular value val, and we will say this dot val or data, whatever we'll say here, data or val is equal to val. So it will consist the value which is passed into the constructor. So the node, if we are putting here 1, then our node will be made for 1. We will have that thing. And if we add n1 dot next is equal to new node which will be having value 2, so we will be creating this particular structure, this much structure, and 2 will be having null. Similarly we will say n1 dot next is equal to new node 3, then we will be creating the exact structure which we have created right here. So now moving on to binary trees. Binary means having two. Simply means having true. So trees are structures which are like something having a root thing and some of its branches. But since we are dealing with binary trees, so we must have only two branches, not the third one. So our binary tree will look like this thing, and every node in the tree must can have 0, 1 or 2 children at most. They can have 2 children at most, and minimum they will have 0 children as well. So let me teach you some brief I'll say terms related to tree. The first one, the originating node, is called the root node. And the last nodes are called the child nodes. These are called the child nodes. These are all the child nodes, and the nodes just above the hierarchy of these particular things is called the parent node. It means that this node is parent to these two nodes. The root node is parent to these two nodes. So let me give you an example for a tree. Let's say we have a tree like having the root node as 1, its child are 2, 3, its child are 4, 5, 6 or 7, and if we have no elements after that, then we can just simply, it will consist of null, because our constructor will be initialized with null, and so on. Also we have a terminology for level of a binary tree. So generally we consider the root level to be level 0. The level after root is called the level 1, and the level after that is called 2, and similarly this scenario goes on. So let's say we have to create this structure from our code. So the first thing we will do is to create the root node. So we will do like root is equal to new node, and we will pass on 1 as the constructor value. This will create the root node. Then we will say root dot left is equal to new node 2. This will create the left child. For that we will create sorry, I forgot one point. Here if we have to create the class for node, the class will contain like this: class node. It will have a value int val, and it will have, since in the linked list there was only one reference to the neighboring node, but right now we have two references, so we will have two next node. We will have two reference nodes. First one is node left and another one will be node right, and its constructor will be like this: node int val, this dot val is equal to val. So now here root dot left is equal to new node 2, root dot right is equal to new node, I will pass here 3. Similarly, root dot left we will have root dot left is equal to new node 4. Similarly, root dot left right is equal to new node 5. Similarly, root dot right left will be 6. So root dot right dot left is equal to new node 6, and root dot right is equal to new node, and it will have the value 7. So in this way we have created this whole tree, and the last the base cases, not the base cases, but the after this all the child nodes, null will be automatically initialized, because our node value will consist the null value if we are not passing anything right to it. And let me tell you, for doing some tree operations we can use two methods, like iteration way and the recursion way. Let me make you understand how we can traverse the tree using the recursive way. The first thing is that traversing a tree have three types of traversals. First is in order traversal, second one is pre-order traversal, and the third one is post-order traversal. In the in-order traversal, we will be exploring first the left node, first the left tree, the right, then the middle, then the root node, then the right tree. In the pre-order, we will be